In this video, we're going to continue working in section 9.3. If you look at your journal for section 9.3, here you can see the general definition of trig functions at any angle. And we already discovered how to do this in the first video. We calculated r using x and y as your two sides of your right triangle, and r is basically the radius. And then you can figure out your trig functions from here. For example, sine is the ratio of y over r. Then in class we talked about the unit circle. We discovered the unit circle. The unit circle is when the radius is just simply 1. So sine is just the y. Cosine is the x. Tangent is still y over x, and the reciprocals are now 1 over y and 1 over x instead of r over y and r over x. Next, the unit circle is just one circle around. So what if you have an angle bigger than the one circle? What you're going to do is refer to a smaller angle called a reference angle. So what we're going to do is be drawing an angle, and the reference angle will be the angle made by where you landed in your angle and then closest to the x-axis. So the terminal side to the x-axis will make your reference angle. The angle will always be smaller than 90 degrees or smaller than pi over 2. If you fall in quadrant 2, you're going to subtract 180 from 180 or subtract from pi. If you fall in quadrant 3, you're going to take your angle and subtract 180 or subtract pi. And if you fall in quadrant 4, you're going to subtract your angle from 360 or 2 pi. This may sound like a lot, but just do what makes sense. Add or subtract until you make your reference angle, which will be smaller than 90 or smaller than pi over 2. So if our angle is bigger than a full circle or bigger than 90 degrees, what we can do is evaluate that angle. First, go ahead and find the reference angle. Then you can evaluate the trig function at your reference angle, which you can use your unit circle for. Then, because you may fall in a different quadrant than the reference angle, you need to determine the sign of what your answer should be. So let's look at the examples. Let's begin with example 2. We're just going to simply use the unit circle for this problem. We want to figure out the 6 trig functions at the angle 270 degrees. So first let's sketch 270 degrees. Each quadrant will be 90 apiece, so we land right here. We call this a quadrantal angle. Now the coordinate at that point, if you refer to a unit circle, is 0, -1. So now let's evaluate the 6 trig functions. 0 is our x-coordinate, the -1 is our y, and the radius everywhere on the unit circle is 1. So sine will be y over r, or -1 over 1, which is just -1. Cosine of the angle is x over r, which we can see is 0 over 1, or just 0. Tangent is y over x, which would then be -1 over 0. 0 in a denominator makes no sense. It makes us an undefined value. Now let's do the other 3, which are just reciprocals. Well, -1 flipped over is simply -1. Secant, when you flip 0 over, 0 goes to the denominator, which makes it undefined. And cotangent, flipping undefined over or flipping 0 onto the top makes it 0 over -1 or 0. Next, let's talk about finding reference angles, because not every angle is going to land on the unit circle and we can use the unit circle. So let's first sketch the example 3a, 5 pi over 3. Now here's 0, here's 1 pi, and coming back around you're at 2 pi. So how would we sketch 5 pi over 3? It may be useful to write this as a mixed fraction, 1 2/3 pi. So if I start here, I'm going to go 1 pi and then 2/3. 2/3 is it's more than half and less than another whole, so we'll land right here. The reference angle is exactly where you just landed, right here, closest to the x-axis. The closest distance would then come to there. How big is that angle? Well, since the whole circle is 2 pi, you can subtract how far we went, 5 pi over 3, and figure out how big that angle is. So what's 2 minus 5/3? If you know how to subtract fractions, 2 is 6/3 minus 5/3. That leaves us with 1/3 pi, or pi over 3. And that is our reference angle. We'll use pi over 3, which can be found on your unit circle. Let's try B. So first let's sketch negative 130. Negative means we go down 90. I wouldn't go all the way to 180. 130 is going to fall somewhere here. Now where I just landed, directly to the x-axis, the shortest distance, that is our reference angle. Well, full line makes 180. If you take away the 130, you can see that 50 degrees is left over to make that straight line. So the reference angle will be 50 degrees. And 50 degrees we could then find on our unit circle. So now we're going to put it all together. We're going to use reference angles to evaluate functions. So first we're looking at the angle negative 240 degrees. So let's draw that. Negative 240 means we're going to go down and around 90, 180, not 270, but right there. So negative 240 is not on your unit circle, but the reference angle will be. The reference angle will be from where you left off directly to the x-axis. How big is that? Use common sense. If how much past 180? So 240 minus 180 gives us 60 degrees. So this angle is 60 degrees. Now look at your unit circle at 60 degrees, which is right here. What is the coordinates at 60 degrees? Your coordinates, your xy point at 60 degrees is 1/2 radical 3 over 2. That's your x, that's your y. Your radius is 1 on the unit circle. Now we want to figure out the tangent at that point. Tangent is y over x. So you're going to tell me the y, radical 3 over 2, over the x, which is 1/2. Now, to simplify this complex fraction, we're going to take the numerator and multiply by the reciprocal, and you can see the 2's cancel. So we're getting closer to the answer. The tangent of 60 degrees we got to be radical 3. But the tangent of negative 240, you may need to change the sign. So what you need to do is refer to your sign for function values here. Okay, and we fell in quadrant 2, and you can see tangent in quadrant 2 and cotangent are both negative. So you need to finalize your answer by making it negative. So the tangent of negative 240 degrees is negative radical 3. Notice we never picked up a calculator to do this, so I do not want decimal answers. Let's try the B. So part B. First thing you want to do is go ahead and sketch your angle. So sketching the angle, I like to make it an improper fraction. 6 goes into 17 2 times with 5 left over. So it's 2 and 5/6 pi. So I'm going to start, 2 is full circle and 5/6 more. So it's not a complete another whole pi. So we're going to land here in quadrant 2. Now the reference angle is exactly from where you landed closest to the x-axis, would be right here. So how big is that? If you take away the 2 pi, we've gone an extra 5/6. How much to get to another full pi? So 1 pi minus the 5/6 pi would leave you with 1/6 pi, or pi over 6. So the second thing we did was figure out the reference angle. Use the reference angle, pi over 6, and look at it on your unit circle. Pi over 6 will be right here. The coordinates for pi over 6 is radical 3 over 2, 1/2. So that's your x, y, and r is always 1, referring to the unit circle. So now let's figure out the cosecant of pi over 6. Cosecant, which is the reciprocal of sine. Now sine is just y, so cosecant will be 1 over y, or 1 over 1/2, which is 2. 1/2 flipped is 2. Now that's the cosecant of pi over 6. We want the cosecant of 17 pi over 6. So cosecant 17 pi over 6. will be 2, but we need to check the sign. So refer to your journal. Because we're in quadrant 2, we are going to look at the cosecant in quadrant 2, and that's positive. So going back to our answer is going to be positive 2. Now I know this is a lot, so we will slowly do the monitoring progress together next time I see you.